All right, today we're going to work on subtracting mixed numbers. And when we subtract mixed numbers or when we subtract any numbers, sometimes we need to regroup. So you're going to see a little bit of that today. Evan walked 2 1/8 of miles to his aunt's house, and he had already walked 3/4 of a mile. How much farther does he have to go? Solve the problem any way you choose. So you can see example right here. They're using a model. That's one way you can do it. And if we have 2 1/8 and we want to subtract 3/4, we follow, if you want to do it using the traditional numeric process, you do the same thing we always do. We want to take a look at our denominators. Are they the same? No. Does one go into the other? Yes. So we can leave the 1/8 alone, turn this into eighths. But now when we're subtracting, we can see we cannot take, change my color here. I can't take 6 away from 1. So I'm going to do what I always did when we subtract. I'm going to borrow. So I'm going to borrow from my whole number, and I'm going to bring my value over. So when I bring it over to add it in to my 1/8, I'm going to bring it over as 8/8. And I chose that so I don't have to do any extra math. So 1 plus 8 is 9/8. So now I have 9/8 minus 6/8 is 3/8. 1 minus nothing is 1. So that's what we'll be working on today, is some subtraction with mixed numbers and some regrouping. And I know you can do this because we know you do the basic strategy you would normally do. So if we had 20 minus 8, 8, you can't take 8 away from 0, so you have to regroup. So we wind up borrowing 10 from the 2 and bringing it over to the 0. So now we have 10 plus 0 is 10. And when we subtract now, we don't get an 8. That's not right. When we subtract now, we're going to be able to get a 2 and bring down the 1. So it's not anything different than you've already done. So a golf ball measures about 1 2/3 inches across the center. What is the difference between the distance across the center of the ball and the golf ball? You can use subtraction to find the difference. When you're looking for difference, you are finding subtraction. So one way you can do it is you can get out your fraction strips, and you set up your fraction strips, do some exchanges on them, and then you rename and you subtract. So they set up their fraction strips. That's what they did here. They renamed. So they exchanged one whole for a whole bunch of little 12ths because they knew the common denominator. Get that. The common denominator for 4 and 3 is 12. That's why they chose to exchange a whole block for 12 little guys. So now they can do their subtraction. If you have fraction strips, you can do it that way. If you don't, and you want to just move right into middle school math and hit our regular numeric problems, and that's what we'll be doing. So sometimes you may have to rename, and that's what we're talking about in this section, renaming a fraction to subtract. And it's simply borrowing like you've always done. In the example above, how do you need to rename the 6? So the 6, let me scoot that down a little bit for you. There we go. So the 6 is being renamed as 5 and 8/8. 6 equals 5 plus 1, right? And 1 can be shown as 8/8. So 6 equals 5 and 8/8. And they picked eighths because there's an 8 in the other fraction. That's how you pick how you want to rename your borrowed digit. You look at whatever the other fraction is. And in the example on page 426, could 2 golf balls fall into the hole at the same time? Explain your reasoning. And yes, they could, because that requires addition. 1 2/3 plus 1 2/3 equals 2 4/3, which equals 3 1/3 when you reduce, and that is smaller than 4.5. So yes. All right, now let's take a look at some of the math problems to work through here. So the first one, number 3, they have us filling in these blank blocks. So 7 2/3 minus 3 5/6. They picked 6 as their denominator because when we look at 3 and 6, a common multiple is 6, so that we didn't have to change the bottom fraction. We just wiggle a 5 in there. The top fraction, to get from a 3 to a 6, you multiply by 2, so we're going to have to do 2 times 2 is 4. And they know we can't subtract 5 from 4, so they're going to regroup. So they're bringing over a whole number 1, and they're going to bring it over, oh, sorry, whoops. I don't like how they do this in this book here. So when they're bringing over, let me write this up here so I can give you a little bit more room. So 7 2/3 minus 3 5/6. So we're going to get some equivalent fractions going here. Realize, hey, I can't subtract. Darn, I have to borrow. And I'm going to bring over 1. This is what they don't have in the book. I'm going to bring it over as 6 6s. So now I have 10 6s, and minus 5 6s is 5 6s. But don't forget your whole numbers. 6 minus 3 is 3. So you wind up with 3 and 5/6. Our book has them jumping right into that 10. They don't have that little step in here that I like. I like to see that you have you borrowed your 1. I want to see what you borrowed it as. So you might have when you're doing the buddy work, it might look a little different. All right, so let's take a look at 5 minus 2 3/4. We'll talk about a common error here. So if you have, what do we have before? 20 minus 8. Common error is kids go like this. They say 8 minus 0 is 8. And really, it's 0 minus 8. So be careful, because this is a really common error. A common error would be the kids would just say, oh, this is 3 3/4. But just think when you are trying to subtract from a 0. There's a 0 over 0 here right now. That's what's there now. So we can't subtract 3/4 from 0 over 0. So let's see what we can do. We need to put something there. So we're going to borrow from the 4. And because we have a 4th over here, I'm going to borrow as 4/4. So would you agree that 5 equals 4 plus 4/4? Sure it does. So now we can subtract. 4 minus 3 is 1. Bring that 4 down. That's our denominator. 4 minus 2. So for number 4, we have 2 1/4. Give myself some more room here. Get a darker color. For number 5, 6 3/10 minus 1 4/5. Remember my rules? Are they the same? No. Does one go into the other? Yes. So I only have to change one of these fractions. I can't subtract because I can't take 8 away from 3. So I'm going to borrow 1 in the form of 10 over 10. So now I wind up with 13 minus 8 is 5/10. 5 minus 1 is 4. And 4 5/10 is written as 4.5 in lowest terms. And then number 6, 9 1/3 minus 4 3/4. Are the denominators the same? No. Can one go into the other? No. 3 is prime, so I can do the 3 times 4 thing real fast. I'm renaming. Remember, 3 times 4 is 12, so 1 times 4 is 4. 4 times 3 is 12, so 3 times 3 is 9. I can't take 9 away from 4, So I'm going to borrow, and I'll borrow in the form of twelfths. So I'm going to add 4 twelfths and 12 twelfths. And when I add 4 twelfths and 12 twelfths, I get 16 twelfths minus 9 twelfths. Sorry, my problem's spilling over down here. So I have 8. Just rewrite it over here. So now I can subtract. So 16 minus 9 is 5 twelfths. And 8 minus 4 is 4. So for that one, I have, oops, wait a minute. 16 minus 9 is 7 twelfths. So I have 4 and 7 twelfths. So don't forget, you need to regroup and borrow in the form of 1, and make sure your 1 that you borrow will help you on your fraction, not make more work for you. Take care.